So I have the double challenge this afternoon. We just had lunch, and we're talking about machine learning. So I'm going to have to make this interactive. So let's start with the question. How many of you leverage machine learning today? All right, so all of you that didn't, you turned off your spam filters already on your email? You just kind of let that spam? Right, machine learning is actually not something new. Now we got a lot of new vendors that have jumped in and sprinkled the magic vendor dust on it and have portrayed it to be something, super sexy and it's going to solve all of your problems, like all of the other vendor solutions do. That's not what this is, okay? What my goal for this talk today is to dispel some of the misconceptions and really convey how easy it is to leverage machine learning today to do some really, really useful things to help your team, especially if you're on the blue side of the fence, although it's certainly useful for red as well, but especially for blue team to really up your game. And so that's the focus of today's talk, all right? So, quick, what is machine learning? It's a subset of artificial intelligence, okay? And what it really is just statistics. It's just statistics, right? So, what we're doing with machine learning is really we're giving an algorithm a whole bunch of data, and we're kind of doing one of two things. There's two main types. One type is basically just looking for outliers, right? So, the keynote this morning, if you caught that was aspects of building models which are often then turned into machine learning, right? So that's an aspect of that. So that kind of taking the data and statistically analyzing it is really the foundation of machine learning. But the good news is there has been so much great development. I'm not a data scientist. I'm not. I am not, a psychologist or any of these other things that a lot of the high-end folks. But you don't need to be today, right? And that's what I'm hoping to impart. We're going to walk through a tool that I built for cyber threat hunting. I'm going to talk about some others. Really what I'm hoping to convey is how easy it is to get rolling in this. So why should we employ machine learning? So the use case I'm going to go for today is a tool that I built called assimilate. And assimilate is a threat hunting tool. It's to help you threat hunt, right? So former employer that Phil and I worked for a few years, right? We do these hunting engagements with an organization. We drop on the ground and we spend typically 2 weeks or a month hunting their environment because they wanted to learn to hunt, one, but two, they also wanted to output, right? And the best way to learn hunting is to do it. It's just one of those exercises. It's like, I kind of actually like the term for the real world because in the real world, I'm not a hunter, right? I don't go deer hunting or anything like that. But I am ex-law enforcement, so I spent quite a bit of time gaining proficiency with firearms for obvious reasons, right? So while I'm arguably more, skilled with firearms than my brother-in-law, who's an avid deer hunter, no question he's a better deer hunter. And of course, the difference is the understanding of deer, right? I know, what they look like. I kind of know they wander around outside, but I don't know that level of habits and patterns, right? That's the key to cyber threat hunting. And that's why machine learning can be so powerful, because I've spent years and years and years honing my ability. So specifically, we're going to be focusing on HTTP headers. HTTP headers are a great place to start threat hunting. Why? Because the real programs in our environment, right, they're almost always going to be using either the Windows, the Linux, or the Mac libraries to build their HTTP transactions, right? Whereas the malware that we're looking for, most of that is hand-rolling the headers. And so if you go and look at the HTTP
HTTP headers, or I'm sorry, the RFC for HTTP rather, it doesn't say, oh, this is the order that the headers should be in, and this is the cases, you know, this header should use camel case and this shouldn't. None of that in the RFC, right? But the libraries on Mac, Windows, and Linux absolutely do have conventions. Little nuanced differences that most of the criminals that we are trying to catch don't know. And so by looking at those nuances, so then, all right, I've spent years knowing what to look for in HTTP headers that are an indication that this is something squirrely that I might want to chase down. With machine learning, what I've done specifically with this tool for this purpose is I've trained it on literally terabytes of HTTP headers, and now I can turn it over to a level 1 analyst who's maybe 2 years in role, and all of a sudden he or she is punching above his weight class, right? That's what I would suggest is the real power of applying machine learning to what we do specifically in threat hunting. Now, there's a big trap that you want to be careful about not falling into with this, right? The trap with machine learning is, if you look at what most of the vendors are doing, they're doing simply anomaly detection. So my day job, I work for a company with 350,000 to 450,000 employees, depending on the time of year, right? Pretty big size organization, right? Petabytes of data that we end up dealing with on a monthly basis. So in that environment, I'd be guesstimate that there's probably about 1 million anomalies a day. Right? Misconfigured server, somebody, you know, a developer spun this up and didn't follow the processes that he or she was supposed to follow, etc. None of which have anything to do with security. So be careful about some of the current vendor solutions because they'll give you a lot of information and stuff to chase down, and 99.99999% of it is going to be noise. And you probably could have found that stuff that wasn't in a lot less time than not using the tool. But that's just his personal opinion, so you know, take it for about as much as you just paid for it. So how do we do this process? So you want to go, okay, you sold me, Tim. Machine learning is a useful tool to have in my toolkit to help find bad guys in my environment. Okay, well, first step is you want to pick a specific problem to solve. The reason why some of the companies, and I want to be careful here, I'm not trying to bash all vendors who are using machine learning. If you look at like Silence and some of those, they have done some really effective uses of machine learning. But they have a really hard problem because they're trying to find all types of malicious files and tune algorithms can do that in really effective. That's a hard problem to solve. They got a whole bunch of people that they hire just to work on those problems. If, however, you take and make a much more granular problem, all of a sudden the scope becomes within what you and I can do pretty easily in our day jobs. Okay? Then we want to decide on our approach. Do we want to use supervised or unsupervised? I'll talk about that in a second. We've got to get the appropriate data. This is where most of the work is. The hardest bit with machine learning is not building the tool and using the tool or figuring out the problem. It's going and getting the right data to train the system with. And we'll talk about that in a second. Then we've got to determine what the proper features are. I'll explain what the features are in a second. Then we build our tool, we test and tune it, and we win. It's that straightforward, right? So those are the key steps that you're going to have to take to build a tool. All right, so let's talk about the problem to solve. So these are some examples. How about finding malicious activity in my DNS, right? And this is especially, by the way, really complementary to signature-based detection, right? Because signature-based detection is incredibly powerful. I will probably leverage signatures till the day I die, right? But with signatures, we have a only know what we know problem, right? If we have a signature for something, we can detect it. But the bad guys are constantly creating new stuff to get ahead of our signatures, right? And when I say signature, I'm using the very generically, like an IDS rule, right? Not necessarily just an AD signature, to be clear here. So those specific pattern matching signatures are really powerful, but they're only going to find what they know about. Whereas with machine learning, let's say if you caught the talk this morning, really awesome talk on the, I just forgot about the name. Yeah, right? So a lot of what was dropped for that was Lockheed, right? When Lockheed was in its heyday, they were iterating it constantly, right? Signature-based detection for that, it means you're constantly updating your signatures. Whereas machine learning, you push a bunch of those Lockheed data samples through it, you've got something that's much more robust, it's less fragile than signatures. Still would use signatures, but they're very complementary, right? How about finding malicious PowerShell activity in Windows event logs? In most of our environments, we have legitimate PowerShell going on, and we have a lot of the actors leveraging PowerShell to drop. So, in case you're not aware, actors like TA530 right now, what they're tending to do is they'll run a malicious document, document with malicious macros. Maybe I need more caffeine. And that malicious macro will spawn PowerShell. PowerShell will pull down their loader, right, or drop it more correctly, right, and load up all the rest of the stuff. So how do I distinguish my admin folks using PowerShell correctly versus my red team being jerks, right, versus the bad guys actually doing it, right? That's a challenging problem to solve. That's actually the tool I'm working on right now. How about finding unknown malicious traffic posing as legitimate applications? We could maybe go at that from the cookie variety, we could go at that from HTTP header variety. These are just some examples to spark, but notice they're all pretty concrete. And this is where current state of machine learning really shines, is if you start with a very specific problem, okay? If you go overly broad on your problem, you're going to have trouble getting machine learning to be effective. Whereas if you put really tight rails, because here's the thing, I don't need to detect all the things with my tool. I'll just write another tool to detect that next thing, right? And train it appropriately. That's where I would posit is the current state of machine learning and where it's really powerful for us, okay? Abnormal activity, you get it. So then we've got to decide on an approach. So there's two basic approaches. Supervised, which basically just means that we direct the learning of the machine. This is generally best for solving very specific problems, right? So very discrete, like I just talked about. But we need labeled data in order to this. So what I mean by labeled data is we need samples of bad and samples of good. Okay? And that's it's counterintuitive, but it's harder to get good data to train than it is to get bad data to train. We get bad's pretty easy to come by, right? There's malwareanalysis.net, there's all of these great resources out there that have got tons and tons of great samples of bad that we can use. But getting good, because if you just use your lab, you're going to skew the results to how your lab works, right? You've got to have real life, real world data, but that is clean, which is a lot of work to clean if you're pulling it out of your environment, right? Then there's what's known as unsupervised, which is we just basically give all the data to the algorithm and say, hey, tell us what's bad. This is really outlier detection. This is the approach most of the vendors are taking right now. And in my opinion, outside of very specific use cases, it's not ready for contact for security purposes, specifically, right? You know, if you take like an example like the TensorFlow engine from Google, right? They use just massive files. Okay, very specific things like that, yeah, it's great, but for general security, you're going to run into problems. So then let's talk about appropriate data. So we've got to have data that's germane to the problem. So in other words, if I'm going to be looking at HTTP headers for anomalous activities, then I'm going to need HTTP headers, right? So if I'm, my current project where I'm working on Windows event logs, I need Windows event logs. Kind of obvious, but kind of important to be clear about. We need some known good data, some known bad, right? We ideally want a lot of both. Generally speaking, and there's caveats to all of these statements, the more data the better, okay? That said, if you're first starting out with smaller piles of data is perfectly fine. What you'll just find is as you get better and better sets of data, then what that does is gives the algorithm more and more, kind of, remember what I said earlier, this is basically statistics in action, right? We're giving this algorithm, whether it's naive Bayes or random forest or whatever algorithm that we choose for our project, we're giving it a data sample, and it is still a machine, right? Learning is a little misleading in the term because it's not learning like you and I learn. It's just running its calculation over that entire data set to get a statistical sample, right? So that what you want to do, one of the keys here, is you take that pile of good and that pile of bad, and you separate it. So you take 80% of it to use for your training, and then you save the other 20% for using for testing and tuning, right? So that's both the good and the bad, right? So when you've separated that out, okay, here's some known good. I've now trained my tool. I run my tool against the known good, and it says a bunch of that is fishy. Well, then I probably need to do some more tuning, right? Same thing on the bad. If I run it against my bad and it doesn't say all of it is bad, then again, we probably want to do some tuning with it. One of the other things that you want to be aware of is we're not going for 100% accuracy on this, right? I'm going to run a demo here in just a minute, because my goal is not to actually PowerPoint it now. And what you're going to find, or what you'll see in the demo, is it finds one suspicious record off a bunch of piles of data, right? That's fine, because what I've done is I've taken in that instance several meg worth of logs, and I've narrowed that down to one log now for me as an analyst to go chase down, right? That's why I would suggest that machine learning in its current, kind of maturity is best for hunting purposes, rather than thinking of it as a detection engine like we would think of a snort or a suricata or those, right? Then the next thing we do is figure out what the features are. Well, the features are nothing more than the specific data points. So in my case, if I'm looking at HTTP headers, what headers do I look at? Do I look at all the headers? Do I look at just the user agent and the URI? What is it that I want to have it examine? The more features we call out, the more complex and slower it's going to go. Whereas there's this beautiful balance point where we get the right set of features, in other words, the right data points for the algorithm to be looking at to classify, and then it will be able to generate and say, oh, here's your bad stuff. So that's really what features are. Also, by the way, this is a really good question to ask vendors. You've got this magical machine learning artificial intelligence solution. Ask them what the features are in the algorithms that they're using. When you get that blank stare, you should probably keep walking. Just a suggestion, right? Again, some of the examples I've used, event ID is a pretty obvious one in Windows event logs, right? But there's definitely going to be other fields from the Windows event logs that I'm going to want to leverage too, not just the event ID. We can't tell if something's bad just based on event ID, right? And the good news is if you build detection rules for like snort or suricata or any of those, you actually already know how to do features, right? It's the same process that we use, or maybe YAR signatures, right? That's another great, if you build YAR signatures, what you've done is you figured out the features to look for, right? Features is just the term they use in data science to call out the data point versus what we call them as fields. Okay? More features, like I said, does not necessarily equal better. Sometimes it does, but often it's just going to bog you down, right? And then the rule of thumb is very simple. If you don't know where to start, just pull in all the headers, right? And then what you can do is compute the variance. So all of the toolkits, so I'm using Python, scikit-learn. Scikit-learn has a built-in thing where it'll parse in all of the data, and it'll compute the variance on all of the different headers. Anything with high variance is a really good target to use as a feature, whereas if you've got a large sample set and you've got low variance in a particular header, then it's much less likely to be a good feature. So that's how most data scientists start figuring out which header, which things they should use as features. Then we build our tool, right? So, as I said, Python's a great option. That's what I prefer. But there's lots of other things that can be used. The reason Python is such a great option is because there's a bunch of people that are at least 10 times as smart as me, probably more closer to 100 times, that are maintaining NumPy, scikit-learn, pandas. So pandas is a data module that'll just handle huge chunks of data, right? Think of that as your data store. And NumPy and scikit-learn are the data science. So they've already written the algorithms, they've already built all that stuff. All you need to do is call them. And you'll see in just a minute, so we're gonna need two pieces of code here, right? We're gonna need a way to parse the data, obviously, right? If it's event IDs, whatever, gotta parse it so we can put it into our data store. We're gonna have to pick an algorithm. The algorithm, if you don't know what algorithm to go with, start with random forest. Random forest is a fancy name that says it tries about half of the algorithms that are possible and picks the best one for it. So, it's when in doubt, a good one to go. I'm actually using naive Bayes in the tool that I'm going to demo here in just a minute. Right? Naive Bayes is the same one that's used in your spam filters. Naive Bayes is really good at things that are textual in nature, as in text. Because that's kind of what it's designed for. And then we'll need training mode and an analysis mode. So what I mean by this is you could write this in one tool just for simplification of showing you what this looks like. I've got a separate piece of code for each, right? So I've got assimilate-train and assimilate-analyze, right? It's just two different, I just broke them separate just to make it cleaner to understand. Because I wrote this not just for using as a tool, but also for helping people, figure out how to do this, right? And one of those tools is only 53 lines of code, and the actual machine learning portion is like 6 lines of code. That's why I'm saying this is accessible to you today, right? It's not heavy lifting, right? Then the trainer's going to need to parse the data, run it through the algorithm, and what you're going to get is what's called a model. Right? That model is basically a vectorization and a statistical analysis of the data that you fed it. So you say that model out, and then the model is what's used to then run up against unknown stuff to make a decision. Okay, is this malicious or is this not malicious? Okay? And then you need the analyzer that loads the model, parses the data to be evaluated, and calls out any items flagged. So let's look at some of this rather than me just talking about it. All right, so I'm going to get this kicked off. So I've got a trained model here. So this is assimilate assess. So I'm going to run this against, you can see a directory there. Well, first off, I'm loading my two model files, vectorizers and NB. Then I'm running it against a directory called assimilate test small. And then I'm going to put any output into a file called findings.txt. And the -v, of course, is just verbose, so it tells what it's doing. So I'm going to start that now because it takes it a minute to load the models because the models are pretty big. While it's doing that, I'm going to pop over here to show you the code. So here's the trainer code. Notice I'm bringing in the modules I need.
And then there's my option setup, right? And then here's where the real work goes on. So we've got here on line 45, right? Oh, let me start with 42, sorry. It's reading in from a directory all the files and parsing them and assigning them the label good. Right? So that's my directory of known good data. Then I've got a directory in 45 that I'm loading. Notice I'm loading it into the exact same data frame called, really creatively data. And I'm labeling that back. Right? That's my malicious data. And then down in 48 is where we start the actual data science stuff, right? So we first do a vectorizer on it, okay? And we have to tell it what to go against. So in this case, I'm using a serial stream of the HTTP headers. So I'm a fan of Bro. If you're not a fan of Bro, shame on you. So there's a module capability in Bro that isn't on by default called Bro HTTP header. Right, so you probably know Bro HTTP. Bro HTTP breaks out all of the individual header components. Bro HTTP header serializes the entire HTTP header. Okay, so I just turned that on, ran it against my Pcap data, right? Bro-R for the win, right? It's your Pcap file, boom, it will process against that, and so that's what's in those those directories. Then I'm classifying it, right? Which is lines 51 through 53, and then 56 and 57, I say got my model files. Literally, right, this entire program is 59 lines long. Sorry, I said 53 earlier. I did put blank lines in between, just to be clear. And then the assess program on the other side just does the opposite, right? So it starts out here by loading the models, right? You can see up there at line, let's see, that's 47. So it loads my vector file and my model file, and then it just iterates through all of the files, and then notice I just write out, oh, that one looks suspicious, and I specify the line number and the log file so that me as an analyst can now go look at it. Okay? So then making sense so far? Oh, and we're done over here, so let me scroll back up so you can see what it did. Bless you. As you can see, it parsed through a little bit of files here. All right, there we go. Get it back to all right, so it loaded, then it started on the directory, right? So here's the assimilate test small. Let me open that, open that up for you just to show you what that looks like. So these files, these are just log files, output from Bro. Oh, let me turn off line wrap and make this a little bigger so you can see it. So these are just the Bro HTTP header output. Okay, so that's the files that I both trained off of and am working off of. So it parsed through all of those, and then it wrote out to a file called, scroll down, it's in here somewhere, there we go. Sure that was done. And so we should have a results.txt here. Findings.txt, sorry. Don't remember my own command lines. Oh, and now I want to turn them back on. So the line it called out is this. Yeah, that looks a little odd. Certainly against my training data. In the end, it actually didn't turn out to be anything malicious. But it was worth looking at. Somebody is, doing a, request against that with a really big basics before encoded object, right? So of course I just started with the basics beforehand and looking at it, right? So that's the power of machine learning. Took a whole bunch of files. Like I say, your biggest work is in the setup. The biggest work is in the getting those clean data and unclean data. And let me show those directories here. Second. So for the mals on this, it doesn't want to make it. You get the idea here. Yeah, I think those are legible. Right? So each one of those is a distinct, and literally what I did was I took a packet capture of the comms from the malware, and then I ran it through bro-r. Then I edited, so one of the key things here that you want to be aware of, so again, if I open up one of these bad files, doing on time, still good. So if I open up one of these bad files, I actually went through every single one of these bad files because there's a whole bunch of noise, right? So when the malware's kicking off, it's going out, it's going to probably query Google, right, to see who has an internet connection. Stuff like that the typical malware does, this background noise. I don't want to teach the machine learning algorithm that going to Google is bad. I want to be probably careful with that, right? So you still need to do a little bit of cleanup on those. But the harder part is the normal traffic here. And I want you, so take a note of the sizes of these log files. So these were about, I think it was about an hour of Pcap capture from some of our bro sensors at work. Few terabytes of log files, and then I cleaned them, right? Went through and scoured them. That's the hard work. That's about 80% of the time. The actual writing the code and all of that kind of stuff is trivial, right? But once we've done that, we now have something. It's easy to continue to refine this. So in this instance, I've now determined, this one that it found on this run, it's actually good. So what can I do? I can take that record and add it to my no good and rerun my train. Right? And that iteration, you end up with a very, very powerful capability. One of and there's a bunch of tools out there at this point already for doing this. Test and tune, yep, I talked about that already. If you're not getting the results you expect, try changing your features. That's a key thing. Again, try different algorithms. That will often give you good different results. And there's great write-ups on Wikipedia and all the stuff. The documentation for scikit-learn talks about all the different algorithms. So there's like 30-some different algorithms supported by scikit-learn. And there's a write-up on each one's strengths and weaknesses and use cases where they're better or stuff like that, right? Ultimately, if you do that and you still have problems, you probably have unclean data. You've probably got some bad stuff and you're good, or some good stuff and you're bad that are causing the models to skew and going wrong. So some examples, clear cut. So this is Chris McCubbin and Dave Bianco. Again, completely open source. This is also looking at HTTP headers, but it actually has two modes. Clear cut will do supervised and unsupervised. So that's kind of fun. Assimilate, there's my link to Assimilate. And if you don't look at any of the rest, go look at malicious macrobot. So this is a gentleman on our team at my day job who's working on his data science degrees right now. I think he's running about a 98% efficacy rate on this, pretty close. So this is just looking for malicious macros in documents. And it blows every commercial program on market away for accuracy.
Pissing out red team.
Yep. So literally, and by the way, Evan created that. So Evan Gausted is the gentleman that wrote malicious macrobot and maintains it. It's a Docker install. So literally, just do a Docker install and you got it.
throw your documents at it, it'll tell you which ones have malicious macros. It's amazing, right? And that's the power that is in our hands today, right? You don't need to be a data scientist. You don't need to be an expert on all of this stuff. You need to understand the steps you need to follow. And I'm not saying that it's not going to be some work, right? So I probably invested about 120 to 140 hours worth of effort in this assimilate. But coming out 120 to 140 hours, how often have we invested that thing that produced much, right? I can give this to my level 1 analyst hunters and have them finding stuff that they would never find there, right? Which in turn then helps them get better, which is one of my core passions, right, is developing talent. So, questions? Sir?
If I wanted to automate this and put this into like a dashboard, how would you go about integrating your tool into something like that?
So the output can go wherever you want, right? So the output I've currently got set to go to, you can either have it go to the display or go to a text file. You can just as easily run it to a Kafka bus, run it to, wherever, right? So easy to do. Generally, you're not going to want this inline per se. Now, the model does support handling constantly updating row log files, right? All of the log files, by the way, said snort-log because the malware I took, most of the malware I collected off malwareanalysis.net, and that's how they captured it. And my script for parsing and processing and all that is renamed the file and added a unique identifier to the end. So you can use it how you want, right? You're probably not going to want it, the key is you're probably not going to want to run it in line. You're probably going to run it from some sort of a batch process pattern where, all right, we'll run it once a day, or run it as part of your hunting exercise, right? Oh, we're going to hunt HTTP headers today, so let's whip out the tool to do that. And my first giveaway is just ideally suited for you, Sean. Sir?
Seems like you have three very clearly defined sets of data.
Yeah.
Good, bad, and new.
Yeah.
I just have data.
Yeah.
Can I tell it just to start showing me things that are anomalous?
You can. That's the unsupervised, right? You absolutely can. But what you're going to get in most data is just a lot more noise that you have to sort through. In most of the unsupervised stuff, without really careful tuning, etc., I would suggest that you'd be better served by starting with some of the data you've already classified. So, for example, start with the stuff that's coming out of your SOC, right? SOC found this malicious on a host. All right, let's run it in our sandbox, capture the Pcaps, run them through, whatever. You could literally do raw Pcap ingestion if you wanted to. Python can handle any data format, ultimately. I would start with, don't go for all those big piles of data out there. Start cherry picking your data for stuff that you think is good and bad. Bad should be based on events and stuff that you're finding, right, to start that out. Or repositories like malwareanalysis.net, right? Pretty easy actually to find bad repositories. It's the good that's hard because you don't want to take that data. But the thing is, you also don't need to overly worry about it out of the gate, right? Because what you can do is take that big pile, train it, take a subset that you think is clean, that you didn't have any incidents today, so you think that's clean, train it, and then test, right? And if it's not producing the results that it should, then go back through the data and see, okay, what am I hitting on that I can clean out as good or bad? Does that make sense?
It does. And then how do you get a feel for how small the data set you can start with would be?
You can start with as small a data set as you want. It's just the smaller your data set, the less accurate your results, right? It's statistics. So the smaller your sample, the less your accuracy of your statistics. It's literally that simple, right? So yeah, and there you go. Other questions, sir?
Are you also qualifying tracking the performance statistics of your
Can you speak up just a little? I apologize.
Are you also tracking the performance of your models?
I do, yeah, absolutely. That's one of the things that so all of the development work, when I'm doing the development work, I'm actually using Jupyter, right? Because I can do it iteratively, I can look into the model and the statistics around the model as I go. And it just works really well that way. But yes, you really should do that, but I didn't go into that because you don't actually need to do that to start with.
No,
You can get really solid models for it. Right?
fine. How does it improve over time?
Oh yeah, that's exactly right. That's where that really becomes important is to look at that kind of data over time, right? So now that I know this is bad, or this one that is flagged as potentially bad is not actually bad, I want to run that back through and keep measuring that so I can determine, all right, am I actually getting more accurate or am I not getting more accurate?
So what sort of false positive rate do you get in your data models?
So mine currently, so assimilate runs at about 70% accuracy right now with a good data set, right? But in my experience, 70% accuracy is more accurate than a level 1 analyst for hunting. So that feels like good enough to start. I usually try and shoot for a minimum of 70% for, threshold. I'm probably running today around 77, 78. Lots more tuning to do to get it clear, but that's just rinsing and repeating the testing and tuning, right? Ultimately. So, and you get a wicked cool shelter, so can you pass that down, please? Other questions? Sir?
A real easy one.
Yeah.
How many records do you recommend working on at a minimum?
It really depends on the data, right? So, I would never use less than like 1 million, right? But mostly I'm using, a few 100 million. So like that training set is probably, I would say it's probably about 5 million records that I'm training for the good. But that's why, back to actually the earlier question about the accuracy, the reason why ultimately that accuracy isn't higher is that means I've still got some outliers in there that probably aren't necessarily good, that I just haven't found in cleaning them. Hard to clean effectively, a billion records worth of stuff. So my last giveaway, did you get a ticket for the after party? Did you want to go to the after party? You got the 20. All right, no worries. No, it's all good. You do have to be 21 to go to the after party, just in case you didn't know. Questions? Questions, sir?
Is there any benefit to sharing your models with other people?
There absolutely are. So Evan's stuff comes with pre-shared model, right? Oh, you're good? All right, there you go. Sir?
What would you say are the biggest red flags to look for if somebody's trying to sell you machine learning snake oil?
Overinflating the benefits is the simple one. And then the second one is when you start digging in, they just, you ask them about the features they're using, ask them what algorithm they're using to train on, right? Just ask them for some of those technical details. And your salesperson, of course, won't necessarily be able to answer those, but if they don't have people that can readily, this is it, and can easily go into the details, and et cetera, you should really question anything that's pure anomaly detection. So a couple of the companies that are doing it well so far are like Swirl out of Boston. So Chris McCubbin, who wrote ClearCut with Dave Bianco, works for Swirl, right? They've got some really good stuff. E8 stuff looks pretty solid. There's a few that I think the vendors are going to get there, let me be clear, but mostly it's an add-on marketing term. Oh yeah, we use artificial intelligence and machine learning. So just start asking them, well, how are you using machine learning? How did you train, what data did you train your models off of? Stuff like that. And almost always they fold up quickly and go, All right, next. Sir?
My question is along that line, so how do you like put value on those products? If it took you 120 hours
Yeah.
to write something like this,
Yeah.
you got 70% accuracy, how much do you pay to get 80 if these guys are paying 80?
I don't pay anything, but, but I'm fortunate enough to have 2 data scientists on my team. So that is a luxury that most folks don't have, to be fair. So that does maybe change the cost equation. But for some of these very succinct stuff, and again, I want to be careful, it's not that some of the companies like Slimeworks aren't doing some really amazing engineering work and really pushing the ball forward. But they are the exception, not the norm. So far, at least. Sir?
In the area of data science, do you have any resources that you would recommend for coming up to speed enough not to become a data scientist? To be able to interact with this site? Like
Absolutely.
that kind of stuff.
So I've been focused on learning for not quite the last 3 years. So I started, so my MO for developing technical skills, I pick a focus area, dedicated a minimum of 3 years for that, at a minimum of 10 hours a week, usually closer to 20 hours a week, focusing on that area. And I'm about, 2.5 years through my data science focus. So I'll probably wrap that up next spring sometime. And so the O'Reilly's got a ton of just fantastic videos and books. There's a lot of great material out there. I don't have a specific one right off the top of my head, but ping me and I can definitely give you some specifics. Sir?
For anybody that's interested in learning, getting into machine learning, a lot of podcasts on the engineering course, which is free. It's a video series you can get Coursera or
Okay.
Consider it at the top.
Nice. I haven't seen that particular one, but they're
About 18 hours.
okay.
It has like exercise videos.
Yep. Most of the really good courses are like video courses, for instance, which this is one of those topics that I mostly like to read books, but there's something about this that a lot of the video courses I found actually more effective for this particular topic area. And most of them are going to run 20, 30, 40 hours in length, and depending if you do all the same things. But you're going to come out the other side with a lot of tools in your toolkit. All right, thanks everybody. Have a good afternoon.